What if Earth really has a second moon and we only found it in 2025? Asteroid 2025 PN7, a 19-meter object quietly shadowing our world since the 1950s, just upended our ideas of planetary neighbors. Is this newfound quasi-moon harmless, or are we ignoring a threat no one saw coming? The real story behind Earth's secret companion starts now. A quasi-moon is not a second moon in the traditional sense. It's a small object, like Asteroid 2025 PN7, that orbits the Sun just as Earth does. What sets it apart is a rare orbital choreography. It stays close to our planet for decades, sometimes centuries, thanks to a near-perfect match in orbital period. This phenomenon is known as a one-to-one mean motion resonance. While our true moon is locked in Earth's gravity and circles us every month, a quasi-moon is never actually captured. Instead, it keeps pace with Earth, tracing a looping path that, from our perspective, can make it look as if it's orbiting alongside us. This arrangement blurs the line between what we call an asteroid and what we call a moon. The difference comes down to gravitational binding. Earth's real moon is held fast by our planet's pull, always inside a region called the Hill sphere, a kind of gravitational bubble that extends about 1.5 million kilometers from Earth. Quasi-moons like PN7 dip into this region but never slow down enough to become true satellites. They remain loyal to the Sun, not to Earth, and their paths are shaped by a delicate balance of gravity and momentum. The term quasi-moon is relatively new in astronomy, reflecting how these objects challenge old categories. Some scientists prefer the label co-orbital asteroid or quasi-satellite, but the effect is the same. These bodies are caught in Earth's rhythm, sometimes appearing to hover near us, sometimes drifting far away. Their orbits can last for decades or even longer before a nudge from another planet or the Sun sends them on a new path. Understanding this distinction is more than a matter of labels. It's the key to grasping why 2025 PN7 was so hard to spot, and why its discovery forces astronomers to rethink what it means to be a moon. As more quasi-moons are found, the boundaries between natural satellites and asteroids become less clear, opening new questions about how many hidden companions might be sharing our journey around the Sun. On the night of August 2, 2025, astronomers at the Pan-STARRS 1 telescope in Hawaii logged a faint, slow-moving point of light. Dr. Robert Jedicke, a veteran of the survey team, noticed something odd in the object's path. While most asteroids streak quickly across the sky, this one lingered, its motion curiously synchronized with Earth's own orbit. Initial software flagged it as just another near-Earth object, but Jedicke's experience told him to look closer. Within hours, the team ran orbital calculations, cross-checking the new data against thousands of known asteroids. The numbers didn't add up to anything familiar. The next day, word spread across observatory Slack channels. Did we just catch a horseshoe orbiter? Graduate students joined the hunt, combing through older Pan-STARRS images and scouring the Minor Planet Center's archives. By the end of the week, they'd traced the object's trail back to 2014, confirming it had been hiding in plain sight for over a decade. But the real surprise came when archival plates from the 1950s showed faint but unmistakable evidence of the same object. Now dubbed 2025 PN7, looping through Earth's neighborhood since the dawn of the space age. At just 19 meters across, it was small enough to evade detection for generations, yet large enough to trigger a flurry of excitement once found. News broke quickly. Headlines called it Earth's second moon, splashing across science sites and social media. The story captured imaginations worldwide. Was this a new natural satellite or something stranger? Experts like Jedicke cautioned that the term second moon was misleading, but the public fascination was undeniable. For a few days, the world was swept up in speculation, with memes, viral videos, and even late-night talk shows weighing in on the mysterious visitor. Behind the scenes, astronomers scrambled to refine PN7's orbit. The initial buzz gave way to a more measured scientific push. Teams at JPL, ESA, and the Minor Planet Center worked around the clock, sharing data and running simulations to understand how this asteroid had managed to shadow Earth for so long without anyone noticing. The discovery sparked a wave of questions, not just about PN7's path, but about what else might be lurking in the shadows of our planet's orbit. At its closest, asteroid 2025 PN7 passes within about 299,000 kilometers of Earth, roughly the same distance as our Moon. This proximity might sound alarming, but the numbers tell a reassuring story. PN7's orbit follows a path almost identical to Earth's, circling the Sun at an average distance of 1.003 astronomical units. Most of the time, it's actually much farther away, drifting out to tens of millions of kilometers before looping back in. Its journey is shaped by a gentle tug-of-war between the Sun's gravity and the subtle influence of Earth, never allowing it to settle into a true lunar orbit or break free entirely. At least, not yet. Simulations run by astronomers show that PN7's dance with Earth isn't permanent. The asteroid has been shadowing our planet since the 1950s, and calculations predict it will continue to do so until around the year 2083. After that, small nudges from the planets will likely send it drifting off into a new orbit, ending its decades-long partnership with Earth. Throughout this entire period, PN7 remains too small and too distant to have any noticeable effect on our tides, climate, or daily life. Its mass is minuscule compared to the Moon, and its gravitational pull is insignificant at these ranges. There's no evidence it will ever cross paths with Earth in a dangerous way. Orbital models show no collision course, even centuries into the future. Instead, PN7 serves as a quiet companion, close enough for astronomers to study, but never close enough to threaten. Its presence is a reminder that not every object sharing Earth's orbit is a cause for concern. Sometimes the most intriguing discoveries turn out to be the safest. Paul Chodas, who leads NASA's Center for Near-Earth Object Studies, puts the question of risk to rest. His team runs the most advanced orbital models in the world, tracking thousands of objects and updating predictions with every new observation. For 2025 PN7, the result is clear. There is zero probability of impact with Earth, not just now, but for centuries to come. This verdict is echoed by David Farnokia, whose calculations at JPL confirm that PN7's path keeps it safely out of harm's way. Their confidence is built on decades of experience, the same expertise that has accurately predicted asteroid encounters time and again. With the danger question settled, attention turns to what this tiny object might teach us. Astronomers are preparing for a new phase of study using every tool at their disposal. NASA's Goldstone radar is scheduled to ping PN7 during its next close approach, sending radio waves across hundreds of thousands of kilometers to map its shape and spin. Spectroscopy campaigns are on the calendar as well, aiming to capture the faint signature of its surface minerals. Each data point will refine what is known about PN7, its size, its composition, and its subtle dance with Earth. There's growing interest in what a mission to such a quasi-moon could reveal. Some propose a robotic flyby, others dream of a sample return. The practical challenges are real, but the scientific payoff could be enormous. For now, PN7 stands as a reminder. Not every discovery in our cosmic backyard is a threat. Sometimes it's an opportunity, one that could unlock new chapters in our understanding of the solar system. Asteroid 2025 PN7 was first detected on August 2, 2025 by the Pan-STARRS 1 telescope, measuring just 19 meters across. Archival images confirm it has quietly followed Earth's orbit since the 1950s, unnoticed for decades. Unlike our true moon, PN7 is a quasi-moon, bound to the Sun but synchronized with Earth, never coming closer than 299,000 kilometers. NASA's Center for Near-Earth Object Studies calculates zero probability of impact, and PN7 is expected to leave Earth's neighborhood around 2083. Yet its discovery raises new questions. How many such objects share our path undetected? What can their composition reveal about the early solar system? While radar mapping and spectral analysis are planned, much about PN7's origins and structure remains unknown. The evidence shows Earth's cosmic environment is more complex than once thought. As of today, PN7 poses no threat, only new opportunities for exploration and discovery.